Welcome. All right, we're going to work in this video on conditional probability. Now I'm going to have to define that for you, but here is the goal. The goal is that you will be able to calculate the probability that one event occurs given that another event has occurred. You'll see examples of that soon enough to understand what I'm talking about, and then we're going to learn a formula that's going to allow us to accomplish what we're trying to accomplish here with this goal. All right, first thing we need to discuss is what is conditional probability, and I'm going to give you a couple examples to kind of illustrate that. Let's just say, generally speaking, that we have a standard deck and we want to find the probability that we draw a heart on a single draw. Well, to draw a heart on a single draw, you know that there are 13 hearts in a deck of cards. 1/4 of them are hearts, right? And, well, out of 52, the probability of getting a heart from the entire deck ends up being 1 out of 4. Okay, now that's going to change, though, with this next statement, and I got to teach you how to read it. You see how in the probability notation I've written heart, and then I wrote this vertical line, and then I wrote the word red. Well, that vertical line that you see right there, in probability notation, you're always going to read that as given. And so what this is asking us to do is to find the probability that we get a heart when we draw a card, given that the card that we draw is going to be red. All right. Now, this is an example of conditional probability. With conditional probability, you're always going to know additional information about a problem that reduces the sample space is really what ends up happening. Now that I'm given that the card is going to be red, I still have 13 hearts, but I've only got 26 cards to choose from because I know I'm going to get one of the 26 red cards. And so the probability of drawing a heart, given that the card is going to be red, ends up being 1/2 instead of 1/4. All right, so conditional probabilities are probabilities when you know extra information about the event. Another example that I won't write down. Let's suppose I was asking you who's going to win the game tonight between the Miami Heat and the Oklahoma City Thunder. Well, you might just say, hey, Miami's won the championship 2 years in a row right now, so I'm going to give Miami a 60% chance of winning. But what if I then told you that LeBron James is not going to play in tonight's game because he's injured? That's going to change the probability, right? And having that extra information, maybe you're more likely to say, all right, I give Oklahoma City a 52% chance of winning, something like that. All right, so knowing extra information that changes the outcome, that's what conditional probability is all about. Now, how do you calculate conditional probabilities? All right, this is the formula that I'm going to give to you right here. And in this notation, the way you're going to read it is that you're finding the probability that A occurs given that B has occurred. The probability of A given B. And the way you'll always find the probability, conditional probability, is this. You'll find the probability that the desired event, I'll call it A, occurs, and that the given event B occurs. Find the value or the probability that they both occur. And what you're going to do is you're going to divide that by the probability that the given event occurs. Okay, so divide by the probability of B. Now, in the example that I just gave to you, where I was saying we have a deck of cards, and we want to find the probability of getting a heart given that the card is going to be red. I'm using a little shorthand here. Well, the first thing we'd have to do is find the probability that the card that we draw is both a heart and red. So there's 13 hearts. There's 26 red cards, aren't there? And isn't every one of the hearts also red? So what we can say is that there was a 13 out of 52 chance that we would get a card that was both a heart and was red. Okay, and then we want to divide that by the probability of the given event, which is the probability that we get a red card. And there are 26 red cards out of 52. So we'd be divided by 26 out of 52. And then all we would do is simplify that. 13 over 52 divided by 26 over 52, that's the same thing as 1/4 over 1/2, first of all. And then whenever you divide one fraction by another, you know to multiply the first fraction by the reciprocal of the second one. So you can make that 1/4 times 2. And that gives you 1/2, which is what we deduced earlier as the probability of getting a heart, given that you're going to get a red card from a deck of cards. All right, so hopefully you've got a good idea of what conditional probability is. And now I just need to show you a couple more examples of where you use this formula in order to calculate conditional probabilities. All right, you're going to want this example written down in your notes, and you're going to want to draw a Venn diagram to go along with it as well. The problem says that in a group of 36 IB students, 16 scored a 5 or better in Physics SL, and 20 of them scored a 5 or better in Mathematics SL. There were 8 students that scored less than 5 in both courses. We're going to assume that everybody in this group takes both courses. One student is chosen at random. Find the probability, first of all, that the student scored at least a 5 in math, given that they scored a 5 in physics. All right, well, before we get into any of the actual answering of probability questions, we do want to go ahead and draw a Venn diagram to represent the situation. So let's do that then. And so we'll call one of the sets here P for physics, the other is set M for math, because those are the two courses the kids are taking. And remember that the way you want to fill in these Venn diagrams, you always want to start from the inside out. We don't know how many scored a 5 or better in both tests, so I'm going to call that X for right now. We know that 16 scored a 5 or better in physics, so this is 16 minus X right there. And we know that this is going to be 20 minus X because there are 20 students that scored 5 or better in math, and, well, the ones that only scored 5 or better in math but not physics would have belonged right there, right? And then you can make your, we also know that 8 students did not score a 5 or better in either one of them. So, out of 36 students, right, 8 of them didn't score a 5 or better in either class. That means the sum of all the numbers here is 28. And if you use a little bit of algebra to do some things that you've already done with me before, you're going to find out that X is equal to 8. There were 8 students that scored 5 or better in both courses, which would mean then that there are 8 that scored 5 or better only in physics, and that there were 12 that scored 5 or better only in math. Now we've done enough work to be prepared to answer the question that is a conditional probability question. What we're asked to do here is, well, we're told to find the probability that a student scored at least a 5 in math, meaning they belong to set M, given that they scored less than 5 in physics. All right, the probability they scored at least a 5 in math, given that they scored less than 5 in physics. Now let's use probability notation and try to write down exactly what we're looking for here. We want to find the probability that M occurs. M in this case being somebody who does score a 5 or better in math, given that they scored less than 5 in physics. That means given that P does not occur. Does that make sense? Okay. And so using our conditional probability formula, what we need to do is we need to find the probability that both of these things occur, that someone scores a 5 or better in math and they do not score a 5 or better in physics. And we want to divide that by the probability that they don't score a 5 in physics. You always divide by the probability of the given event. Okay, well, how many people scored a 5 in math and did not score a 5 or better in physics? The people that fit that description are going to fit in this region of our Venn diagram that I'm highlighting right there, right? There were 12 people out of the total 36 that scored a sufficient score in math, but not in physics. Oops, I'm just trying to change this to a pen and I keep being unsuccessful. All right, 12 out of 36 is the probability that of M and not P occurring. And then what's the probability that somebody did not score a 5 or better in physics? Well, there are 16 people that did score a 5 or better in physics. The remaining 20 people then did not score a 5 or better in physics. All right, now let's multiply by the reciprocal. That's going to give us 12 over 36 times 36 over 20. 36 is canceled. You're just left with 12 out of 20, which of course then is 3/5. 3 in 5 chance that somebody that scores at least will score at least a 5 in math, given that they did not score a 5 or better in physics, according to this data set. That would not always be true, of course. Now let's look at one more problem here. Oh, no, sorry, a second part to the same problem. So I'm going to copy the Venn diagram over here. Give me a sec. This time we want to find a probability that a student scores 5 and better in math, given that they score a 5 or better in at least one of the courses. All right, the probability notation for that then. The probability that M does occur, that they score a 5 or better in math, given that they score a 5 or better in at least one of the courses. Now, if they score a 5 or better in at least one of the courses, that could be these people right here, could be these people that scored 5 or better in both, or it could be these people that scored only in math. What I'm trying to get at then is that that is the union of sets P and M. All right, now to calculate that probability, we've got to find the probability of both those things happen. So we've got to find the probability that somebody scores 5 or better in math, and they scored a 5 or better in at least one of the courses. And we've got to divide that by the probability that they scored a 5 or better in at least one of the courses. Always divide by the probability of the given event. All right, let's highlight some things here. See if we can figure out this first complicated looking thing here. We want to find out where is the intersection of set M with the union of sets M and P. I'm going to do a couple little highlightings here. If we're trying to find an intersection, we want to know where two things will overlap. Well, here is set M, everything that's right here, correct? And then let's use a different color. Pink will work for me. And let's shade in the union of sets M and P. It's right here. The place where those two things overlap happens to be this area right here. It just happens to be set M. That's where the two shadings overlapped. So set M is the intersection of M with the union of M and P. And let me clear this up so we can actually see the numbers in there again. There were 20 people that fit inside of there. So a 20 out of 36 chance that that occurs. All right, if you need to rewind and watch that explanation, I highly recommend it because that was a little bit of a difficult thing to digest the first time through maybe. Okay, then what is the probability that either M or P occurs? Well, the probability that somebody scores a 5 or better in either math or physics would be based on these three groups right there. 8 plus 8 plus 12, that's 28 out of 36 kids that did at least one of those things. Now, if you do the whole multiply the first fraction by the reciprocal of the second fraction again, the 36s will cancel, just kind of like what they did last time. You'll get 20 over 28, and then you'll simplify that by dividing each by 4, get 5 over 7. All right, now for one more example, and it's just basically the same thing, but with the information presented to you in a little bit different fashion. This time I've drawn a table, and I'm telling you that that table shows the number of adults and children in a sample of 80 people who chose Pepsi or Coke as their preferred soft drink. They had to choose between the two, basically, right? So you can see that there were 35 people that chose Pepsi overall, 13 children, 22 adults, 28 children in total, so forth. And I want us to find these probabilities. First, let's find the probability that somebody prefers Coke, given that they are a child. Prefer Coke, given that they are a child. Okay, so the probability of Coke, I'm going to use that CO because I also have CH for child. Given that they are a child, oops, I'm putting that in the wrong place, aren't I? It would be equal to the probability that somebody chose Coke and they were a child, divided by the probability that they were a child. Now, how do we determine these things from the table? Well, if I want to find the probability that somebody chose Coke and they were a child, let's look in the Coke and the child column. That's 15 out of the total 80 that fit that description. And if I want to find the probability that somebody was a child, well, that includes this number plus this number. There were 28 total children out of 80. So we're going to divide by 28 over 80. Then go ahead and multiply by the reciprocal. You get the 80s to cancel. 15 out of 22 is a chance that somebody was a Coke drinker given that they were a child. All right, and then finally, want to find the probability that somebody is an adult given that they prefer Pepsi. So the probability that they are a given that they prefer Pepsi, we'll call that P. So we've got to find the probability that somebody is both of those things, that they're an adult and they prefer Pepsi, and divide it by the probability that they prefer Pepsi, regardless of age. Okay, the people that were adults and prefer Pepsi, that was 22 out of 80. And then the people that just preferred Pepsi, well, there were 35 out of 80 that did that. That might be getting a little bit difficult to read. Nah, you can see that well enough. Do the division, the 80s cancel. 22 out of 35 is what you're going to end up with there. Okay, so you now know the formula for calculating conditional probabilities. And, well, hopefully the couple of examples have helped you learn how to use it as well. Thanks for watching, everybody. Hope it's helped. I will see you next time.